Good afternoon. It's been a pleasure being here this week. I arrived on Sunday and I spent 4 days going through memories of 40 years ago when I was actually sitting in an animal science or a biology or chemistry class. And about the only thing I could remember was the 16 essential elements of crop production. And how many of you remember the C. Hopkins Cafe method of remembering that? Few of us older ones probably had to do that, but it's been really enlightening to see the progress. As was mentioned, I farmed full-time up until 2004. Back at that time, we were just starting to utilize some of the GMO technologies with Roundup Ready, the BT, things like that. So I didn't understand the chemistry and the biology behind all of that, but I really appreciated as a farmer of not having to go out and hoe weeds and spend excess chemicals and to be able to transition to no-till. But as was mentioned, in April, I transitioned into a new role with the CAAFI organization. The aviation sector is really taking serious sustainability and environmental compliance. And this just illustrates many of the initiatives that they've taken on over the last several years, focused on reducing noise emissions, changing the components in the plane, going to carbon fibers in the construction, fuel efficiency. And so they really look at the environment as something that they have to really focus on. One, because the customers expect it, their stockholders expect it, and then also international policy is moving in that direction. They also look at the ways of reduction greenhouse gases. And so both the aviation sector, this is a group of the equipment manufacturers, companies like Pratt & Whitney, GE Aviation, Boeing, Airbus, have all signed commitments on ways of improving the efficiency and reduction of carbon intensity in their flights. The airlines themselves have made different levels of commitment. Some have actually invested in biofuel projects. Others have committed to buying a certain quantity of sustainable aviation fuel by certain deadlines. And so they're all collectively working to help reduce the use of fossil-based fuels, but also the carbon intensity of flying as well. The ICAO, International Civil Aviation Organization, represents over 193 national governments. And if you look at this, you'll say, well, all we have to do is repeat what we did in 2020 and 2021, and our issue with carbon abatement is settled. Anybody remember what happened in March of 2020? The world sort of stopped there for about a year and a half because of COVID. And I think if we remember the inability of travel, we weren't able to fly, we weren't able to have face-to-face communications with our business partners around the world, how much that interrupted our businesses and our way of life. Now, we did learn to Zoom and Teams meetings and things like that, and we've become more efficient, I think, with our communication and our business dealings. But those of you that have been here this week, you can't replace the face-to-face interaction. Those of you that are younger students, having the opportunity to meet colleagues at a meeting like this, develop those relationships, develop mentorships, you can't really put a price tag on that. And we are today a global society. And I think it's very important that we be able to travel and meet in settings like this. And the only way we can do that is through flying. I guess you could get on a boat, but you'd spend more time traveling than you would attending the meeting. So really the only opportunity for the aviation sector is to replace fossil fuel with some type of a biogenic carbon-reduced fuel source. And we consider that sustainable aviation fuel. And a lot of the work is trying to come up with new fuels. And if you look at this, technology can play a part. But I was at Boeing Aircraft last week, and a new plane will go into service, and it'll last for 35 to 40 years. It's not like changing, cars every 5 to 7 years. So the technology is in place today, they expect it to last. Operations and infrastructure. You can improve efficiency, and computer models are figuring out how to have the planes at the place they need to fly based upon consumer demand, but you can only take that so far. So sustainable aviation fuels is the primary driver. The other opportunity is market-based measures like paying a carbon tax or some type of a carbon deferment program and things like that. In the United States, it's being led both by federal agencies as well as the airline sector. Back in 2021, the current administration established the Grand CAAFI Challenge with two major benchmarks. By 2030, having 3 billion gallons of domestically produced sustainable aviation fuel, and by 2050, having 35 billion gallons of sustainable aviation fuel produced here in the United States. And so those are pretty ambitious goals. Well, how do we do that? Several years ago, the Department of Energy, Department of Agriculture commissioned a study called the Billion-Ton Study. And basically, they were looking at all types of bio-based resources and to see how much was available for biofuel conversion. And so they determined it was at least 1 billion tons that could be harvested sustainably for some type of biofuel production. That study has been updated a few times, and they just released another update in 2024, and that one shows that there's over 1.5 billion tons of potential bio-based products that are available. That can include dedicated energy crops like miscanthus, switchgrass. That can also include woody biomass, and also include things like crop residues such as corn stover, wheat straw, and etc. And so within the Grand CAAFI Challenge, there's several different pillars. One is feedstock innovation. What can we develop as new crops or new feedstocks that could feed into that? Conversion technology is critically important. If you've got wheat straw or corn stover or fats, oils, and greases, how do you turn that into jet fuel? And then the building supply chains. You've got it at the farm level. You've got, within the grain system, we have elevators, which would take the grain initially from the farmer. Then it goes to some type of a processing facility. Then it goes to a fuel terminal, and then finally to the end customer. So building all of those supply chains in place so that we can move things from the soil all the way to the plane. Policy and evaluation. How do we do that? We're talking about creating a fuel that doesn't exist today or is just becoming available. And so do you do that with tax incentives? Do you do that with technology grants? Do you do that with some type of a mandate? And trying to figure out what the unintended consequences of all those decisions are. And then enabling in use. Does this product work exactly like traditional fuel, or do you have to make some modifications to the equipment in order to make it work? And then communicating with all the stakeholders. If we're asking farmers to produce a new crop, we have to communicate education, what type of equipment, what type of economics, and then also with the end user and everybody in between. So what is sustainable aviation fuel? Traditional jet fuel is considered a paraffinic kerosene. So basically, if you take a 42-gallon barrel of crude oil, you create various products. About 50% or a little less than that winds up going into gasoline. Then you have a diesel component. Then you've got a naphtha component. About 10% can be refined into jet fuel. And all that depends on the type of crude and where it's sourced. And so, there's a lot of fudging on those numbers depending on the quality of the crude and what the market is demanding for those products. But with that fuel has to meet certain requirements for the airline sector to be able to use. If you think about it, if you flew here, you were probably traveling at 35 or 40,000 feet. You're talking about 40 or 50 degrees below zero. So that fuel has to have a very low freeze point. If you've ever dealt with gasoline, if you get a match too close to it, it's going to flare up or blow up. That jet fuel has to have a very high flash point because you're dealing with people's lives in a contained container. Then the fuel has to have certain properties, lubricity, the gaskets and the seals within that plane. It has to be able to be measured so that the pilot knows how much fuel is left as they're flying. So there's lots of different factors that go into that. So ASTM certifies the fuel, and so we have to create a product that meets basically all those specifications. When we developed ethanol, we started with just a 10% blend in order to make it work within our normal combustion engines. Biodiesel, we started at 2%, 5%, 10%, now we're up to about 20%. Renewable diesel is basically a complete replacement for diesel fuel, but all of these different products, you had some leeway on the equipment. Basically, the airline sector is saying that in order for us to use the fuel, it has to be basically identical to the fossil fuel that we're using today. And so there's been 8 different pathways that have been approved of using different feedstocks and converting those all the way to basically a Jet A type fuel. And so some of the key things, we've seen progress. CAAFI, the organization, was started in 2006 with an effort of getting the airline industry to say what's going to be needed in order to produce a fuel that will work under their requirements. We've worked with federal agencies to help them understand the challenges and the opportunities of producing this fuel. And so most of the pathways that have been approved today is you can take 50% of that product and use it in a 50% blend with traditional jet fuel, and the plane operates exactly as it would if it was using 100% jet fuel. In some cases, we're seeing other improvements beyond the carbon reduction of those fuels. We're seeing less emissions. We're seeing a higher density of that fuel, so that means you carry less weight when you're flying, and that also improves fuel efficiency. So we're seeing a number of different benefits of using SAF other than just trying to meet the carbon goals. And so this sort of shows the evolution. Back in 2006, I mentioned the CAAFI organization was formed. There was a lot of interest at that time from the federal government and the military on looking at, can we develop fuels that are domestically produced that can be used both in the Navy, the Air Force, and different applications. And so there was a lot of investment from the military and the U.S. government in that space. As we started getting better technologies in 2016, we started moving over to the commercial side. And once again, that fuel has to have the safety of traditional fossil fuel. We have to work on the cost competitiveness of it. And then the big issue today is making sure that there is a carbon reduction compared to fossil fuel use. And so the goal is to have that carbon intensity score for sustainable aviation fuel no greater than 50% of its fossil fuel that's being used today. And the goal is, eventually to lead to a zero carbon fuel. And so last year in the US, it was 25 million gallons production of sustainable aviation fuel. And we're on pace to having a little over 100 million gallons this year. So I mentioned the goal by 2030 is to have 3 billion gallons. And so we've got a pretty aggressive goal and agenda in front of us. This shows some of the projects. We have a company called Montana Renewables in Montana that's producing 30 million gallons last year. LanzaJet is one that just opened this year in Georgia. They're going to be producing 10 million gallons. The difference between those two, the Montana renewables, they're primarily using beef tallow as their feedstock. The LanzaJet in Georgia is primarily using alcohol, ethanol from sugarcane that's produced in Brazil. And you might ask, why would you be bringing ethanol from Brazil if we're producing over 15 billion gallons of ethanol in the United States? It gets back to the way that the carbon intensity of that fuel is being scored. And currently, the opinion is that our corn being produced in the United States has a carbon score too high to fit those objectives. There's a lot of discussion taking place now. Can those farmers employ climate smart agricultural practices and lower the carbon intensity of the grain and eventually get corn-based ethanol down below those thresholds? The same with using different types of fats, oils, and greases. A lot of the aviation fuel and the biodiesel and renewable diesel is being produced from used cooking oil. 20 years ago, that was a waste product. Now it's a very valuable commodity. And so what types of crops, what types of fats can we utilize in order to produce those fuels? And so there's different technologies and different ways of producing that. And then all these others are projects that have been announced, and many of those, they already have the financing arranged. Others, they're still putting together financial packages and site selection and things like that. But, if all of those come to fruition, we're looking at 2 billion gallons by 2028. So we're heading in the right direction if we're wanting to get 3 billion by 2030. But once again, the bigger goal is the airlines would like to replace all their fuel by 2050 with renewable fuel, and that's going to take 35 billion gallons. So pretty big market opportunity. Another opportunity is utilizing existing refinery capacity. And so there's lots of different types of feedstocks. I've mentioned fats, oils, and greases and sugars and starches, but also using lignins and converting those through some type of a pyrolysis or gasification process or other technologies. I've seen lots of those kind of graphs over the last 4 days, and the goal that I guess we'd be asking of those scientists in the room is, help us develop or provide us the technology and a crop that can be harvested from our farms and fields, that has disease resistance, that requires very little inputs, that has a very high oil content, that is very easily to convert in jet fuel. And to do that in a way that the farmer can make profit growing it, and in a way that the commercial community can turn that into a price competitive fuel. And so if y'all can solve that problem, we've had a really good week. So I put that challenge out there for you. And so, all of these are potential pathways. I mentioned 8 different pathways have already been approved, and those have to go through strenuous testing and fuel analysis and actually test flights and things like that. And so the easy approach is through the fats, oils, and greases. We're looking at other types of oils. You're going to be talking about Camelina over the next couple of days. There's been reports on pennycress, and there's a southern group working on carinata. We don't want to forget about soybeans or canola or other types of traditional crops. So there's lots of opportunities there. But I look forward to the presentations over the next 2 days on the progress that's being made with Camelina. We really are excited about that opportunity because, if we can take land that's being fallow during the winter months and be able to grow a commercially viable crop on that helps reduce erosion, improves disease issues between those transition crops, that's a win-win for everyone. And so, we're seeing the projects become more and more commercially viable. The research that you all are doing is helping to make a huge difference there. We're looking for different ways of making it more competitive, and there's been federal money invested in some of the projects. There's also tax incentives related to lowering the carbon intensity of those fuels. And the key for the investment community is, one, they want to make sure the technology works. And so, if we go back 10 years ago, we had some cellulosic ethanol plants that got constructed but weren't able to operate. And so, that leaves a bad taste in the mind of a legislator that's elected to office every 2 years. And so it's important to show that these projects are viable. It's also nice to know that the customer is there. The aviation sector wants these products, but they have to meet those other benchmarks as well. This is the guy that's supposed to be here today, my boss, Steve Zonka. Many of you may have met Steve. Steve was an engineer with General Electric Aviation. He joined CAAFI as their executive director back in 2012, and just has a tremendous amount of respect within the aviation sector and within the agriculture community as well. He's been an advisor on many of the projects looking at intermediate oil seeds, and so I know he would do a lot better job of answering the questions that I'll be able to do, but I'm more than happy if you have a few specific questions. I do want to do one thing, and I never was able to do this in school when I was in college without getting in trouble. And so that was just a quick demonstration of taking those plant-based lipids and turning it into an energy that actually flew a plane. So it is possible. Thank you.
Any questions?
Yeah, quick question for you.
Yeah.
The different routes to produce SAF, the different routes to produce SAF obviously have different overall carbon intensities. What sort of value do you place on the differentials?
That's a big question for open discussion. In Europe, they have specific mandates. Right now, the airlines are expected to reduce their overall carbon intensity. I think it's about 10% by 2030. And so, if they don't meet those benchmarks, then there's pretty hefty penalties against that. In the United States, currently, it is incentive-based. And so I mentioned there's two different tax programs. There's a 40B program that expires at the end of this year, and then there's a 45Z that starts in January. 40B was actually approved 2 years ago, and they just got the rules announced for it a couple of months ago. The 45Z, they still don't have the rules announced for that. So the intent is the greater the incentive, the more the carbon intensity is reduced. And so there's a couple of different methods of calculating that. The international method is through a group called CORSIA, the Carbon Offsetting and Reduction Scheme for International Aviation. In the United States, we recognize a greenhouse model called GREET that's developed by Argonne National Laboratory. And so both of those score things a little differently. And it really gets into that life cycle analysis on how do you calculate certain things. And so there's default values for everything. There's a default value for corn, a default value for soybeans, a default value for sugarcane ethanol. And to just give you an example, the baseline for fossil fuel, let's say, is a score of 90. And so that means that for a sustainable aviation fuel in the United States to receive any base incentives, it has to have a score of 45 or less. And then for each percent it goes down, that tax incentive goes up. And so corn has a default value going into an ethanol plant of around 29. We've got farmers that are calculating their scores and are getting down to almost a zero carbon intensity because they're no-tilling, they're using cover crops, they're applying animal waste instead of commercial fertilizers. So I think there's some opportunities of doing that, but something like used cooking oil, that's, potentially going into a landfill or becomes a waste product. So the carbon intensity for that feedstock is going to be relatively low. And so as these programs and these markets develop, we think that there will be an incentive placed on buying products or utilizing feedstocks that have the lowest carbon intensity. And so, the airlines are looking at, okay, what can we do in order to lower overall score? And so if you're blending a product that has a 0 carbon intensity with something that has a 90, you're going to meet your benchmarks a lot quicker than if you're doing something that's got a score 45. So sorry, it's a long answer, but if you were in Europe, depending on which country, the values would be one way. Here in the United States, it would be completely different.
One more quick question.
And I'll be here the next 2 days, so please hunt me down. I'd love to visit with you.
Thank you. You showed the structure of an oil or triglyceride. How much does the composition matter in terms of chain length or number of double bonds if it goes into HEFA and other processes? Can you just crack it regardless? Or?
Someone in here would be a lot better at answering that question than me on the chemistry of it. But, as I showed you, depending on the production pathway, the initial feedstock, we can have tremendous variability. And I know a lot of the product that's being used in the United States for the conversion is used cooking oil. But we're finding out that most of that's coming from China. And there's some speculation that may or may not be all used cooking oil. There may be virgin seed oils that are going into some of those shipments, or palm oil going into those shipments. And so, depending on how they have the system set up and what catalysts they're using and what kind of parameters they're working under, there's quite a bit of variability. But somebody on the production side could probably sit down and say, this is our ideal product coming in. And, if you give us this, then our system's going to work a lot more efficiently. But, you can use black grease out of a sewer trap, and you can convert that into jet fuel, but it takes a lot more challenge. And then we got a project that's been under development in Las Vegas that's using the municipal solid waste through a Fischer-Tropsch syngas conversion process, and they're doing that. And there's even talk about using captured CO2 and converting that directly into sustainable aviation fuel. So lots of opportunities. All are going to have different capital expenditures, and all are going to have different technologies, different catalysts, different enzymes, different ways of producing it. So thank you so much.
Thank you.
Thank you.